Good morning, everyone, and we are the Sunday Show. My name is Artem, and I'm joined by my magnificent co host, Serge.
Hello, Artem. Nice to hear you again. Thank you for having me. Hello to all our listeners, and let's start. Artem, what we are going to discuss today?
And I'm happy to have you with me today as well. Our today's topic is space colonization. So I know this is a very controversial topic, especially right now, but we will be discussing the pros and cons of space colonization in our current day and age. So we're going to be going through how the colony are going to be established, what are the acceptance criteria of a colony, say if we can call it this way, what are some controversial opinions, and what are the main challenges. So big show today and big discussion. So Serge, tell me, how do you see the colonization? What is it in a sense?
Yeah, thank you for such a great introduction, Artem. Uh, truly great topic. Honestly, space colonization is a thing which was uh, something close to everyone in a sense that we hear about it, see something about it in movies, in some pop science shows, and uh, to be frankly speaking, when I was a child, when I was a teenager, I was absolutely fascinated by the idea of us humans building some space stations, colonies, cities, military bases on other planets, on asteroids, in the void of space. And
Military bases.
absolutely, most, I would not say most of science fiction pieces, but many of them are deeply connected with the idea of conflicts and confrontation between different forces in space.
Like Star Troopers.
Absolutely, Star Wars. I'm not sure about Star Trek, but there are many movies, books, sci-fi stories, and when it comes to your acquaintance with this topic, how did it happen? Maybe you remember some book or movie from your childhood which impressed you and made you interested in this topic?
Honestly, I think there's been so much media that is covering the space colonization and space exploration at this point that we have came in contact with it in any case. So I think the one that stands out for me personally would be, um, I think, Star Trek. The exploration part of it, the seeing of new worlds and establishing connections with new worlds. That's something that's really fascinated me for a long time. And what I find lacking in most of the science fiction that I've read is the intricate details of colonization. So, what were the ordinary lives of first 10 people or 20 people who arrived at the planet to establish a colony? How are they categorizing and classifying the colonies? So, uh, I always compared it to how colonies were established in 15th, 16th, 17th century. And I was thinking, would it be that different and would it be that difficult? What do you think?
I would say that it's a great point, and I agree that in many pieces of science fiction, authors, film directors they intentionally or unintentionally avoid talking about this practical part of establishing space colonies. And to be honest, I heard comparison between great European exploration of unknown lands, settling there, which was happening in 16th, 17th centuries. Some, philosophers, scientists, they trying to draw this line of logical, metaphysical connection between our exploration of oceans and unknown lands and continents here on Earth and exploration of unknown places in the space. But in science fiction, obviously, for entertaining purposes, they avoid talking about it. But you're right. In my opinion, connection between those two activities is obvious, and I think we should analyze the similarities between those two types of colonization, but not from the standpoint of philosophy, I don't know, like idealism that people, they want to discover, people are driven by some forces to expand into unknown land. Not from this standpoint, but from a standpoint of practicality and economics. What do you think about my idea?
I think that's a fantastic idea, and I think we should delve into it. So, from economic standpoint and practical standpoint, what do you think would be I would say the acceptance part of calling a settlement a colony, and how do you think it would technically go through?
Thank you for your question, Sartsun. I think it's a very good place to start. What should we? You mean what sort of settlement?
Yeah, how it started basically, how it's starting.
What we can actually consider a colony? This is your question. Yeah, I mean, if we delve into official definition, what colony is, it's most of the time something is considered a colony when a settlement of newcomers is made in a new land, which is inhabited permanently. And it's, I think, very, very standard definition, and people would mostly agree with me. Would you agree with my definition of a colony?
Yeah, but I would expand on it. So basically it's a settlement, but at the same time, it has to be a self-sufficient settlement that is able to provide necessary resources for its own survival and doesn't depend on the outside help. For example, if you recall the colonies from 15th, 16th centuries, they were self-sufficient to the point where they were exporting goods to the mainland.
Exactly. This is exactly the thing which stopped me in my production of definition of what colony is, because I didn't want to say that a place should be considered a colony only if it is self-sufficient. My criteria was permanent inhabitants of that place. But there is, I think, there is a contradiction, because if a place is permanently inhabited, but it's not self-sufficient, I think it should be considered an outpost, like
Yeah,
our bases in Antarctic, right?
yeah, definitely. I think you
When
can
it
even
comes,
argue that some places on Earth are still considered outposts because they are not self-sufficient. They can grow foods there or provide basic utilities.
I mean, what places are you talking about?
I believe some settlements in Greenland can be considered that.
Oh, absolutely, absolutely. Maybe some settlements in Siberia, in Canada, maybe in some deserts. Okay, any settlement which is not self-sufficient, at least when it comes to basic necessities or some basic product which they can export and then finance their colony through those means. Uh, those places should definitely be considered outposts, not colonies. But let's elaborate on this definition a bit more, because I think there are a lot of speculation in media, primarily in media. I think in scientific community they are less widespread. In media, in movies, in science fiction, um, authors, directors, they always demonstrate us some sort of economy existing on our planets, in space. Uh, Many startups are actually being created in modern world, which are offering us, they're not even offering, are selling us and their investors idea that they can uh, realistically extract certain resources in space and then sell them and profitably sell them. So, what is your opinion on uh,
I think we know what you're talking about.
realistic development of economy or industry in space? What is your opinion?
That's a great question, actually, because I heard those startups propose an idea that we can extract gold and platinum from certain asteroids.
Mhm.
And that would be a very interesting topic to delve into, because from practical standpoint, we'd need to go into technicalities. What would be the cost of fuel? What would be the cost of automation of resource gathering? What would be the cost of just transporting goods here and there? There is a good chance that it will be more expensive than to just dig them out from Earth at this stage of development in our technological advances, but I think it's for now unrealistic, at least in the next couple of decades. What do you think?
Um, I think you are totally right, and I completely agree with you. And I would like to add to what you said is that besides those factors which we need to take into consideration, there is the most important factor. What about the market? Who is going to buy this or that product, if we can consider a raw resource product? who, who is going to buy this, let's say, product on Earth? And how that industry is going to compete with other players providing same or similar research on Earth. This is a very speculative topic, and it exists in, I think, in our media field for a while already. And what I would like to suggest is we can delve into the idea of into those ideas, like what we can do in space, what are the places where we can extract certain resources, what are viable planets according to media and pop science. What examples come to your mind when you hear about viability of colonization somewhere?
I first thing I think about is Mars, because we keep hearing about it from
Yeah.
every single place, namely SpaceX right now. And that's a very important conversation to be had because we are really set on colonizing Mars right now. There is countless plans, for example, moon to Mars infrastructure,
Yeah.
and there is a lot of money going into that. For example, I believe SpaceX was advertising that they will be pioneering the space exploration, including space colonization on Mars. But apart from that, I heard a ton about Kepler planets. Have you heard about Kepler planets?
Actually, I am familiar with this name, and I must say that I didn't hear that much. But as far as I know, those are so-called exoplanets, right?
Yeah, that's correct. Exoplanet is a planet that is located in a livable range, so to say. That's calculated distance between the star itself and Earth-like uh, ring, so to say, of the
Mhm.
orbit.
Sorry for interruption, but I would like to add that the most important uh, part of this um, term is that they are located outside of our solar system and they are orbiting other
Yeah,
stars, right?
that's correct. Yeah, but at the same time, Keplers are only looking at the livable range, so to say. So
Mhm.
they're trying to locate the planets that will be Earth-like. And with those exoplanets, they're located quite far from the Earth. I think the closest one is approximately 250 light years away, which is 250 years of traveling at the speed of light. You can
Not
imagine that
very
it's not,
close.
yeah, it's not exactly a stroll around the neighborhood.
Absolutely.
And the furthest planet that is Earth-like is approximately 1500 light years away. So
Mhm.
that will be quite a long time for
Quite
humanity
a
to reach.
journey.
Yeah. And those planets are located via Kepler program, which is finding
Mhm.
the Earth-like planets. And they use two methods that are most popular.
Mhm.
First is microlensing. Have you heard about that
Mhm.
one?
I'm not sure. I don't think I am familiar. What is this? Can you please explain this method in more details?
Have you ever had the situation when you're looking at the sun and between you and the sun there's another object and it feels like there's two suns at the same time?
Mm,
For
I think
example,
I think
during
I
the eclipses.
experienced it a couple of times. Yeah.
During the eclipse, that's something that you might see.
Mhm.
Basically, it works the way that whenever between you and another bright object is something heavy, like moon in this case,
Mhm. I see.
you will see not one object but two. And that's how the telescope locates the necessary planets, because the extortion of the light can be mm, calculated by the mass of the object that is
Mhm.
interfering with the
So it means
view.
that gravity of our body affects flow of light from star, and by how this flow of light was affected, we can calculate some characteristic of or one that or another planet, right?
Yeah, that's correct. And that
Very
happens only
interesting.
because we are using the lens.
Mhm.
So that's one thing, and microlensing has already uh, produced, I think, approximately multiple hundreds of results at this point. Let me pull up the data here. So currently,
Mhm.
confirmed exoplanets uh, achieved location of almost 300 or 282 planets this way.
Mhm.
And another one is by using the transit. So transit is similar. Transit method is basically when you look at the star with a telescope, and you can calculate the brightness of the star. And when the planet does the turnaround on its orbit, when it completes the orbit, like Earth does in a year, when the angles align and the planet comes right in between the telescope and the star, the
it
star
does the
brightness
transit between observer and the star.
Correct, yes. The brightness dips.
I see.
And this dip is not very serious. I would say it's, according to the data, it's approximately 84 points out of a million. But the Kepler telescope detects it.
Insignificant change.
Yeah, and the telescope still detects it. And according to this dip, they can calculate the weight and the radius of the planet.
Fantastic.
So it's not like we have this super powerful telescope that shows us the whole planet. It's more of a mathematical equations that happen.
And we so-called scholastically are making a conclusion about what are the characteristics of certain object situated in a certain solar system hundreds of light years away from us.
That's totally correct. But at the same time, the exactness of the research that's allowed by the Kepler program is approximately 95-96%.
I see.
So it's highly likely that the data that's produced by the Kepler telescope is actually close or exact to what we receive.
I see. Very interesting. I would like to add that I think I watched some documentaries in a childhood, and they made me familiar with the second method, which you described, when a planet does a transit between a star and the telescope, and this way the telescope can detect certain changes in light and in other characteristics. I heard that this way planets which have atmosphere can be, first of all, detected, and on top of that, we can analyze the composition of the atmosphere of certain planet. I think I'm not sure that I remember the definition correctly, but I think it's called spectral analysis. Have you heard about it?
I have heard about it, but at the same time, I think it would be helpful if you go into detail on that one.
I cannot go that much into details because I'm more interested in economic part of this topic. But as far as I know, the composition of light detected when planet does transit in front of its fellow star, composition of light detected this way can tell scientists what are the elements present in the atmosphere of that planet. As far as I remember, they do this so-called spectral analysis, and they measure the black lines appearing on the spectrum. So they decompose piece of light into the spectrum, into those 7 colors, and they analyze how they shift, how they how spectrum is composed, let's say.
Yeah, and
And
at the same time,
this is the method.
we need to remember that light itself is basically a wavelength. So
Exactly.
just for clarity, the telescope, it's not like the person that's using the telescope can see the black lines or something. It's more of a hardware slash software program that decodes the wavelength.
Mhm.
So it gives you the wavelength of a certain color, for example, or a certain light frequency.
Yeah, yeah. This is exactly what I wanted to say. But moving forward into this topic, have you heard about any suggestions about colonization of any object inside our solar system
Oh,
besides
yeah.
Mars?
Only Mars. I have heard only about Mars. Have you heard about anything else?
Yes, actually, what fascinated me in the past is the idea of colonizing Moon, which is actually not uh, doesn't look very difficult because Moon is, according to what we say, is not far away, relatively not far away, of course. And many times I heard about the idea about extracting mining helium free on the lunar surface. Have you heard about this element?
No, I haven't.
Helium free is actually a very interesting resource. This is a radioactive mineral. Let's say I'm not sure. I will not insist on this definition. Maybe some physicists or chemistry experts will define it better. But this ore, radioactive ore, can serve the same purpose as uranium ore does, and provide us with electricity created by our nuclear technologies. But what's interesting is that unfortunately, this helium free ore cannot be used in our existing nuclear power plants because they work on technology called fusion, which means that uh, ore, uranium ore, um, decays and falls apart inside our reactors, and this is how it creates heat, and the heat produces electricity. Uh, for helium free, we need not fusion reactors, but fission reactors, which create heat and consequently electricity not by collapse of atomic structure, but the opposite way, by collecting atoms and pressing them together. It is a fascinating technology. For now, it's in experimental and development stage, but there are many projects. Famous ITER in the south of France, famous Chinese laboratories. They work on creation of working fission reactors, and colonization of Moon is deeply intertwined with the development of this technology, and I always felt very interested in um, in this possible industry. Have you heard about any other ideas about moon colonization, or not really?
I haven't heard a lot about moon colonization, and thank you so much for delving into fusion and fission technologies. It's
Mhm.
really a fascinating topic. I think we can touch upon it in a separate episode, actually, because there's
Yeah.
a lot to unpack there, uh, especially with the media, and there's a ton of things. As for the moon, I think there are inherent risks to colonizing moon.
for
as
example.
if economically it wouldn't make any sense except for the possible development of technology with the fusion reactors that you've mentioned.
Mhm.
And at the same time, other than that, it's more. I heard it's being discussed as being an outpost where you basically build a couple of infrastructure projects that allow you to more easily go to other planets. But
Mhm.
as Moon as the end all be all colony, I haven't heard that word.
Yeah. I would only add that what I see right now, honestly, what I see most of the time is the idea of an outpost. There are different iterations by different actors, different space agencies, different companies, different visionaries, which are not backed by any institutions. But yes, very rarely we can encounter a concept of full scale moon colony or a moon city. It's more like a speculative fantastic due to number of factors, lack of atmosphere, very big problem with radiation, uh, temperature fluctuations, and many, many other things. We can list them. We can make a very long list. Um, but recently, when it comes to creation of outposts, I think SpaceX, NASA, Chinese Space Agency, they all are talking about colonizing South Pole of Moon. Do you know why?
Not really.
Actually, there is a very surprising reason why. Because on the South Pole of the Moon, there is a region which is not seriously affected by the sun, because as on Earth, because the axis of rotation of Moon of Earth is tilted, uh, the sun does not move very high up in the polar regions most of the year. In on Earth, situation is a little bit different. We have polar night, polar day, but according to what I know, on the Moon, um, even when sun appears, when the sun is rising above the horizon, it does not go very far, and consequently, there are some craters in that region, in the polar region, which were not um, exposed to the sunlight for billions of years. Can you imagine that?
Wow, billions. And what would be the significance of that?
And why is it significant? Because according to recent discoveries, uh, those conditions, they created a situation when water ice can be possibly trapped there for those billions of years,
Hmm.
and those huge untapped reserves of water ice can be just waiting for future colonizers who can take advantage of presence of this resource and use it for uh, getting water, getting oxygen, getting hydrogen, which is important component of fuel. And this is basically the premise for all further actions. Uh, Elon Musk, NASA, Chinese Space Agency, they all are considering creation and outposts there. And in my opinion, it's very interesting. But let's come back to practical part. Would you like to discuss economic viability of any project? An outpost, a colony,
Sure.
different conditions in
Before
different
we do,
places.
just one thing about Moon. But how
Yeah.
would it actually hold itself with no magnetic field?
Uh, do you mean
Like atmosphere, I think water, oxygen, everything. It's basically the stepstone for an atmosphere.
yeah.
Or you mean that they will be using this ice slash frozen water
Mhm.
only to produce something artificially without actually trying to establish an atmosphere there?
Absolutely. We're not talking about terraforming. Like terraforming for our listeners is terra is earth in Latin, and terraforming is creation earth-like environment somewhere else. Of
So
course,
just as a
nobody.
resource in that case.
Yes, like a research. Nobody is talking about terraforming moon because it's mostly speculative sci-fi concept. So they are planning to mine the water ice, melt it in enclosed space, and use it for different purposes. This is the idea in broad
Gotcha.
sense.
Okay. In that case, let's jump into the economics. So,
Sure.
there were a couple of researches about economic frameworks and viability for Mars colonization.
Mhm.
So, let's go through the numbers.
Yeah, I would be happy to hear them.
So, on the number scale, we need to understand that there is scalability part. For example, if two of us go somewhere, let's say we're using a car. Let's use the grounded example first.
Yeah,
Let's say you and I use one car that uh, takes like 3 gallons per 100 miles, or like
yeah.
10 liters per 100 kilometers. Uh, Whenever we are traveling together, we will split the cost. So if it costs us like $50 to get gas,
Mhm.
when each of us chimes in, it's gonna be $25 a person.
Good
But if
deal.
we take five people, it's gonna be $10 a person.
Even
And that,
better deal.
yeah, and that applies to the space colonization as well. If we have
Mhm.
a bigger colony at the magnitude of 100,000 people, it's gonna be much cheaper than just establishing the colony itself. So the initial cost of colonization, when we have hypothetically large scale settlement with a minimum of, let me see, with a minimum of 1,000 people,
Mhm.
approximately, each person is costing $40 million US dollars per year. That includes cost of transport, cost of living, setting up quarters, setting up artificial sources,
Environment.
yeah, artificial environment where you would be able to receive oxygen. So that means closed system,
Mhm.
water, food, medicine, everything. That comes up to around 40 million per year per settler.
And how many settlers in this
Around
model?
1,000.
1,000, I see.
So that would bring us to $40 billion per colony per year.
Per year. So this is upfront investment which is needed for establishing it.
Yep.
It's more than GDP of many countries, I
Yeah,
would say.
and to sustain it for a year, let's actually compare it to GDP of countries in US
Interesting.
dollars. So 40 billion. Um,
So it's bigger, I think it's bigger than 50, not a very big countries,
yeah,
bigger
I'm
than
pulling
their
it right
economies.
now. So let me see. 40 billion. 40 billion is more than
I think there are like not very big countries like in Africa, in Asia, in South America, like Paraguay, I think does not produce very big economic output.
Yeah, so that's approximately on the level of Cyprus, Estonia, Georgia, which is a country in uh, West Asia or
Mhm.
Eastern Europe, whatever you prefer, not the state of Georgia in the United States, Albania, Haiti, and approximate of Jordan and Paraguay. So yeah,
Yeah,
and
actually, I
to
checked
finance
the
it for 10 years, it would be $400 billion. Now that's
absolutely,
bigger than Denmark.
absolutely. And what's important, we're talking about the size of economy in general. So all businesses, all enterprises in a certain country from our list, they produce this many goods and services in financial terms. Yes, so we're not talking about money which are just existing somewhere in a bank account, which can be just taken and directed into building something. We are not even talking about a budget of a state. So we are talking about a very big amount of money, and of course, some private equity, investment banks, sovereign wealth funds, investment funds, they can provide this money. But those money spent on creation of a colony, uh, are they expected to come back in certain way? Will this colony produce something? Artem, what
No,
can
it's only for self-sufficient purposes. It's not for obtaining any money at this point. So the colony, the only way that this is going to be viable is for the colony to grow and be more self-sufficient, but it will still rely on Earth. And the only way that it comes to, uh, cheaper costs is
Mhm.
if the colony grows to 10,000 people.
Mhm.
In that case, it would be 1 million per person.
I see it will be cheaper. It will lower the upfront investment.
Yeah,
But what
cost per
what is
person.
the what is my point of concern is that uh, people in the past, they were moving somewhere in order to get better life. People were moving to America, into Australia, other places, because they knew they can live there, they can work, they can generate wealth, and eventually they will have better life conditions. This was the motivation of regular settlers. When it comes to institutions, uh, the countries, they were creating those West Indies Company, the most famous one. Other companies which was which were working for extracting wealth from other places, extracting resources. Uh, when we are talking about space colonization, are we talking about generating wealth, or we are talking about, for now, we're talking about creation a place where people can live, and that's it.
Yep, just that's it. Nothing to export for now. This would be more economically viable only if something is located on Mars itself. So, for example, if we find some rare material or rare ore that would be helpful for Earth, in that case, there could be a return. But for now, this is the upfront costs. And on top of that, let's go through orders of magnitude. For example,
Mhm.
if we get a colony that would be 10 million people, which is
For
huge,
example.
like
Yeah,
I think size of New York, give or take, the city itself, New York City.
of course.
Um, then the cost per person would be $100,000. So those numbers will go down as long as we increase the number of people. But on top of that, there is another challenge, economic challenge, which is income inequality. So the more people we have on Earth, the less inequality is there on mathematical scale.
Mathematically, yes.
Mathematically. So, for example,
Yes.
if we take Earth income scale and we take a look at the whole population, we will see that, well, the inequality will start dropping the more people we have. In space, it's going to be exactly the opposite. We will start off with inequality and we'll end up, the more people we get, the more unequal in terms of wealth they will get. And
Very
income
interesting.
scale will be even worse because currently, the more people we have, let's say the more people we have, the more workforce we have, more viable it is for the enterprises and for people to survive. Because there is still a
Absolutely.
production. Of course, there is limited number of resources and limited possibilities and opportunities, but at the same time, as long as we are aware of the trends of the previous century and this current century, the income scale and income inequality has been correlated. Inequality has been dropping, income has been rising, number of people has been rising with tremendous scale. In the beginning of 20th century, there were more than 1 billion people, currently 8 billion, and more of people are living a better life. With space, it's going to be complete opposite. The more people we have, the more problem we will have in a colony.
Absolutely. And we are not talking about technical part of this issue, how exactly we are planning to provide Earth-like conditions for all those people, because we need to create enclosed spaces. We need to build the systems which will provide people with protection from radiation, protection from UV lights, protection from micrometeors, with
From dust on
air.
Mars.
What else?
Dust on Mars.
Absolutely, which is actually very sharp and can cause damage even to very firm metal objects. And on top of that, we need to provide people with water besides air. On top of that, we need to provide people with food. So somehow the colony should at least, we're not even talking about production of, we're not talking about some industry, because there are no viable proposals about creating industries on Mars or somewhere else which will be profitable. We're so far we're talking about probably about creation of local farms which will have to provide people with enough food supply. And as far as I know, in Antarctica, there are no outposts where people grow in greenhouses, where people in greenhouses grow vegetables and they create sufficient supply for the people there to rely exclusively on their local production. They still need constant flow of supply from outside. And the same applies to the outposts, because we cannot call such places colonies. Definitely, those are just outposts in space, which will constantly need a supply of certain goods from outside. And honestly, this reality seriously contradicts the idea of colonization itself, because most in the past people were colonizing places with better natural conditions, with better economic opportunities, and this what drove people to move there and create industries there, because they could extract something useful and have not very quickly, but have better quality of life.
Or get return on their investment.
Absolutely, because investment entails return on investment. And unfortunately, I don't see any viable models for space colonization which would repeat uh, colonization history on Earth.
Yep, totally agree with you on that one.
Would you like to add something to my speech?
Honestly, I think you've covered it pretty well. I totally agree with you on every point that there is, but at the same time, talking about technology and shielding from radiation and that part, that's another big challenge with Mars because as of right now, we're not fully developed to go to live on Mars long term.
Yeah.
Also, another challenge that I think we should discuss is psychological or social challenge. For
Mhm.
example, you mentioned Arctic and Antarctic bases, which is a
Mhm.
great example of how people start acting when they're isolated. For example, there is a great, just fantastic medical article which evaluates medical risks on uh, in confined environments. For
Mhm.
example, if we take a small crew of people, let's say 4 people, and they are left alone for a different number of days without the advanced medical capabilities, Earth's
Mhm.
medical capabilities, be it surgeries, etc.,
Mhm.
medical supplies that are only created in mainland Earth, so to say, in
Mhm.
civilized places. The average expectancy of a crew health will be
Mhm.
approximately 40%. So there is a 40% chance that after 1 year, 4 people crew will not experience any medical events without the medical support.
Not very positive perspective, I would
Yeah,
say.
and with full medical support, so for example, if there is at least limited uh, technological
Availability.
capability to produce any help, then the number would be approximately 80% after a
Mhm.
year. And
Mhm.
that's just 1 year.
Yeah.
Now, about the psychological background that I mentioned, um, the common conclusion is in the medical community as of right now is that people will start mental health of people who are participating in the quote unquote experiment of colonization
Yeah. Experiment.
will go badly down in approximately 6 months.
Yeah.
What's going to happen first and foremost is conflict.
Mhm.
Conflict after 6 months will grow uh, on a scale of 150%. So if you had, let's say, 10 conflicts, after 6 months, it's going to be 25.
Mhm.
Cohesion, the effectiveness of the work with other people, will drop approximately 25%
Mhm.
after just 6 months. Individual performance, which is the most interesting, uh, I would say,
Component.
value, yeah, or element,
Mhm.
would drop approximately 18% after 6 months and 25% after 9 months. So basically, what we have is that people cannot stay in confined environments for a long time with other people with the same level of efficiency and effectiveness as in the beginning.
Yeah. Would you like to add something?
No, that's pretty much covers it. What do you think about the psychosocial part of it?
Yeah, I think you covered it pretty well, and thank you very much for this insightful data. I totally agree with those sobering insights. And what I would like to say is that it reminded me a couple of experiments. I think we can also call those episodes experiments besides Antarctic outposts. In the past, I think in 1980s, 1990s, there was quite famous experiment in Arizona desert called Biosphere 2, where a team of volunteers intentionally enclosed themselves in a totally artificial environment in Arizona desert called Biosphere 2. This place was intentionally repeating the general idea of space outpost. It was a enclosed dome, resembling in some sense a greenhouse, where people were supposed to stay for a year without any physical contacts with outside world, like they would do in space outposts. And that experiment gave basically the same results which you highlighted in your article. In article
The
you
overall
described
decrease of performance?
absolute overall decrease of performance, decrease in many other indicators. People were divided into separate hostile groups, and basically that experiment ended with failure. And it basically repeats the conclusions we are pointing on during our today's episode. What else? Also, I decided to mention famous, let's say, experiment conducted by Soviet Union in the past century called creation of chain of Arctic outposts on the coast of Northern Ocean, in deep in Siberia, in Arctic desert, in tundra. I think the most famous place is called Vorkuta. English speakers call it Vorkuta. Maybe it would be more familiar for our English for our listeners which have English language as their first language. Vorkuta. Now it's even more famous than in the past because it is completely abandoned. Why it happened? Because in the past, Soviet Union had planned economy, and Soviet government intentionally directed resources into creation of those settlements, creation of comfortable environment there, heating, plumbing, sewing system, and energy, everything, infrastructure needed for people. And even in those conditions, people didn't want, for some reason, voluntarily go there.
Why would that be?
Why would that be the case, really? The only way Soviet government could direct people there was Arctic salaries, which were multitude times higher than salaries in places with comfortable climate. Also, people were getting some benefits when it comes to retirement. They could retire literally in their 30s. And this was basically the only method how people would move into those remote areas. And as soon as Soviet system collapsed, planned economy stopped providing everything to those places, people left. People immediately left, and those settlements, cities, they are in ruins. So the same, and what's interesting, there is summer. Summer is relatively comfortable. First of all, there is
So there is a
oxygen.
period when you have comfortable conditions. It's not
Absolutely.
fully confined to a, let's say, building or to a
Absolutely.
closed quarters.
Absolutely. And even when it's polar night, you can go outside. And if you go outside, it would not be comfortable, but you don't die immediately. You can breathe, you can walk. Of course, people should not stay outside for a long time because they will get sick at least. But you can breathe. In space, space is unlike all places in space, all planets or all objects in our solar systems are multitude times more hostile, dangerous, and uncomfortable than any desert on Earth. Arctic desert, tropical desert. In our deserts, we can at least breathe. Radiation does not hit us, UV lights do not hit us, and temperature fluctuations, they exist, but those fluctuations, they are not temperature does not move from minus 100 degrees to plus 100 degrees. It is
Celsius.
it's not the case on Earth. In the past, in the beginning of 20th century, people, scientists, anyone, they didn't know what are the conditions on our bodies of our solar systems. Of our solar system, many people, they envisioned canals on Mars where water was flowing and Martians were growing food, and people expected that those are places with basically Earth-like conditions, but with untapped resources where we can grow food, hunt animals, basically like it was on Earth when we were colonizing Siberia, Americas, Australia, and other places where people from Europe were moving and they could get huge amount of untapped resources. On space, situation apparently end up to be different, where it was very sobering conclusion when very sobering discovery when our first probes in 1960s finally measured the conditions on Moon, on Mars, on Venus, on our bodies, and they discovered that conditions there are much, much more hostile than conditions in any desert on Earth. And if we see on Earth that people don't want to live in deserts, don't want to live in tundra, don't want to live in Antarctica, the only way they move there is strong institutional incentives, so like for financial benefits. They do this trade-off. They agree to live in hostile environment, but in return they get a lot of money, some social benefits, etc. And nobody intentionally colonizing tundra, nobody intentionally colonizing deserts and many other hostile environments. And when we see that it doesn't happen on Earth, the very logical question comes: why would anyone do this outside Earth? What would you say, Artyom?
I think it's mostly because of the feeling of exploration. I think
Yeah,
if, let's say you mentioned Siberia, let's say if Siberia was uh, uncharted territory, I think a lot of people would go just to uh, be the pioneers and try to
yeah.
see what's there. I think that's similar idea with space, and I think we've painted really grim picture at this point about the space colonies. So I wanted to ask you: have you heard about any opinions that are different from ours?
Yeah. Honestly, I have heard about many opinions, and I would say most of them are not grim and they are positive and they are very optimistic. But it took some time to discover that real life is painting a different picture. But what I would say, uh, maybe is not very not what our listeners would expect to hear after all the challenges and conditions we mentioned described, is that we actually should do space colonization for a very surprising reason. Would you like to remind our listeners what was BAM project in Soviet Union?
Oh, that's an interesting. I don't
Turn.
think I know where you're going with that.
Mm, So, would you like me to explain about BAM project, or because I
No,
wanted
I
to
can
give you?
explain. I'm just curious, like, where are you going with that?
Well, I will
Was
explain you.
because
What was BAM
BAM is Baikal Amur mm,
railway?
Railway, yeah.
Yeah.
I was thinking maybe there is a more fitting word because, like, it's not standard
Magistral,
railway. Yeah,
magistral in
something like
Russian.
that.
Yeah.
So basically, I can understand the idea of it, and it was extremely important for communication and infrastructure in the Soviet Union, and especially in uh, Far East.
Mhm.
But I struggle to see where you're going with that.
Yeah, I see. I see. Like, so I will remove this mystery cloth from my idea. Why I refer to BAM project? BAM project, besides its infrastructural and economic importance, which was actually not very clear in because it was planned economy, uh, had other um, side. One side was economic, political, another side was ideological. Soviet Union in 1970s still had very big portion of young people in on its territory, and unfortunately, like in many uh, modern societies, people which don't experience challenges, they start to experience crisis of their existence. They don't know what they are doing, and it creates political tension. It creates a risk of spread of different extreme ideologies, which can be harmful for a state, for a system, and for a society. And the idea behind that railway project was not only economical. The idea was to give people, give society inspiration, give them a feeling that they are doing something great, they are doing something important, and they can become part of it. And I dedicated some time into exploration of this topic. I watched some interviews with builders of that railway, and I must say that this idea worked. People were excited, people were inspired, people felt that they are doing something meaningful and important. It was very interesting social experiment, in my opinion.
So you think
And
we should colonize space to keep people occupied, force them into space,
exactly,
and then
exactly.
they will be more
This
fulfilled?
will never be economically viable, will never be profitable. Any object in space will not be sufficient. It will be a black hole for resources. But it can give something which is not measured in money. It can give people inspiration. It can give people sense of purpose, and it can give people believe that future holds something great. It's idea reminds me building of pyramids in Egypt. Um, According to most researchers, pyramids they didn't have practical purpose, but people were building them, and they felt that they are doing something important. They were getting paid for this, like it was in BAM project in that railway. People who were traveling into Siberia to build that railway, they were getting paid very well. They had access to um, many goods which were not available in other regions. The same idea existed behind pyramids in Egypt, and the same idea can be used for creation of political ideology and creation of more inspiring climate in a society. So, in simple terms, like it was actually in Soviet Union, people had a choice: go drink vodka or go into a club of where people were constructing, RC or radio controlled RC gliders or toy rockets, and those people who were occupying themselves with those activities were more happy and more inspired. And if we, as a society, as a global society, introduce this idea into masses, of course it would be useless economically. It will not work as it should, as colonization should, but it will inspire people, give them feeling that they do something important, and it will be a great way to fight depression existing around the world in the modern age. What do you think about my unexpected turn?
I think it has some sense, but at the same time, a bit counterintuitive. So it has to give meaning to people, but at the same time, in confined environments, they will be more depressed.
I mean, nobody should really travel to space. They can be actors filming their life on outpost from Hollywood. People would just, create societies, astro space colonization society of Europe, space colonization union of America. People would go there, discuss different concepts, engineering solutions. They will create competitions who will became who can become an astronomer, and not astronomer, astronaut. I mean, and most people don't have to actually travel into space. People should just be involved into space-related activities, and this would give them sense of meaning. Like people who were building pyramids, they weren't getting a place inside. Only Pharaoh, only their leader was getting a place in a tomb. Not everyone who was building that railroad in Siberia was supposed to be a train driver. Yeah, like
Yeah,
people were
and
just
no one
lying.
is commemorized out of those builders.
Mm, this is not actually needed. they need those people, they needed to feel that they are doing something important, and this was given them sense of purpose while they were alive. And this is the function of such project, and I think this function should not be overestimated, and it should not be underestimated, because they can have very profound and positive impact on a society, in my opinion.
That's an interesting outlook and an interesting approach. I think it gives the positivity and hope that we long for. And I think with that, we can wrap up the episode. So thank you so much.
Thank you so much for this episode, Artyom, and looking forward for the next episode.
And in that case, if we don't see you and hear from you, have a good afternoon, evening, and good night. Thank you, everyone.